Hello viewers, in today's session we are going to discuss another important and conceptual problem from limits involving the absolute value function or the modulus function. So here we have to discuss the existence of this limit, that is limit x tends to 0, and here the function is given as mod of x minus 3 minus mod of x plus 3 divided by x, right? So here in order to discuss the existence of this limit, we have to make use of the definition of mod function, right? So if we use the definition of mod function, then we can easily arrive at the right hand limit and the left hand limit of this function when x approaches to 0, right? So here in order to test the existence of this limit, we'll find the right hand limit and the left hand limit, and then we'll draw the conclusion, right? So let us first see the definition of mod function, and then we'll calculate separately the right hand limit and the left hand limit when x tends to 0. So let us first see the definition of mod function, right? So here a mod of p is defined as positive p whenever p is greater than 0, or p is positive, and mod of p is equal to 0 when p is equal to 0, and mod of p is negative p when p is less than 0, right? So viewers, the solution of this limit, it lies in the definition of mod function. So if we correctly apply this definition of mod function to find out the right hand limit and the left hand limit, then we can draw the conclusion. So let us first find out the right hand limit. So for right hand limit, what we will do, see here x tends to 0. So now if we draw the real number line here, and here we have the point x is equal to 0. So when we find out the right hand limit, we approach from the right of x is equal to 0. And when we find out the left hand limit, we approach from the left of x is equal to 0. So when we get or we find the right hand limit, then we move towards x is equal to 0 from the right of x is equal to 0, and we arrived at a point in the neighborhood, that is the right neighborhood of x is equal to 0, and this point may be taken as 0 plus h. And when we approach x is equal to 0 from the left of x is equal to 0, then we reach at a point which is known as the left neighborhood of x is equal to 0, and here this point is 0 minus h. So to get the value of right hand limit, we take x is equal to 0 plus h, and remember this h is infinitesimally very small, and it is a positive quantity, and it lies between 0 and 1. So this quantity h is very small, right? So we can take x is equal to 0 plus h when we find the right hand limit, so that we have simply x is equal to h. And when x tends to 0, then h tends to 0. So here the notation for right hand limit is given by limit, and here we can write x tends to 0, and here we write a positive sign, and here we have f of x. So our function f of x is given by mod of x minus 3 minus mod of x plus 3 divided by x. So now we can transform this limit in terms of h. So we have limit h tends to 0, and here we have x is equal to 0 plus h, or x is equal to h. So we have f of h. So now we can write limit h tends to 0. F of h is obtained by replacing x by h. So we have mod of h minus 3 minus mod of h plus 3, and here we have for x we have h, right? So now we have to take care of these two terms, that is the mod functions. So we'll use this definition. Now see, h minus 3. Now since h lies between 0 and 1 and h is infinitesimally very small, so h minus 3 is going to be a less than a 0, right? And h plus 3. Now see, h is a positive quantity and 3 is also a positive quantity. So h plus 3 should be greater than 0. So from the definition of mod function, now we can write from here mod of h minus 3 is equal to a negative of h minus 3, because this quantity, if we take h minus 3 as p, then mod of p is equal to a negative p when p is less than 0. So here h minus 3 is less than 0. So we have mod h minus 3 is equal to minus h plus 3, right? And similarly here we have h plus 3 greater than 0, and we can now write mod of h plus 3 is equal to positive h plus 3, because mod of p is equal to positive p when p is greater than 0. So here h plus 3 is greater than 0. So in this case we have taken p as h plus 3, right? So now this limit takes the form limit h tends to 0, mod of h minus 3 is minus h plus 3. So here we have minus h plus 3, and here mod of h plus 3 is equal to positive h plus 3, which is simply h plus 3. So here we have h plus 3, and in the denominator we have h. So now we can simplify this expression in the numerator. So we have minus h plus 3 minus h minus 3, and here we have h. Now this 3 and this 3 get cancelled, and minus h minus h is minus 2h. So we have now minus 2h over h. Now this h and this h get cancelled, so we have limit h tends to 0 minus 2. Now this quantity is independent of h, so we can omit this limit notation. So we have simply minus 2, right? So the right hand limit of this function when x approaches to 0 is given by minus 2. So here we can write the right hand limit, that is minus 2. So now let us calculate the left hand limit. So the left hand limit, the notation for left hand limit is limit x tends to 0, and here we put a negative sign, and here we have f of x. So when we find the left hand limit, we take x is equal to 0 minus h, and again h is infinitesimally very small, and h lies between 0 and 1, right? So we have x is equal to minus h. So when x approaches to 0, from the left of x is equal to 0, then h tends to 0. So now we can write this limit in terms of h. So we have limit h tends to 0, and here we have f of minus h, because x is equal to 0 minus h, that is x is equal to minus h. So now we can write the value of f of minus h by replacing this x by minus h. So we have mod of minus h minus 3 minus, and here we have minus h plus 3 divided by minus h. Now again we have to take care of these two terms, that is the mod functions. So again we'll make use of this definition of mod function. So let us first see this quantity, that is minus h minus 3. Now see, minus h minus 3 can be written as minus, and here we have h plus 3. right? So this quantity is negative, that is minus h minus 3 is less than 0, right? So we'll make use of this part of the definition. Mod of p is equal to negative p when p is less than 0. So if we take this quantity as p, then we have p less than 0. So mod of minus h minus 3 can be written as negative of p. So p is minus h minus 3. So here we have minus minus plus. So we have minus minus plus. So we have simply h plus 3. And similarly, here we have minus h plus 3, which can be written as 3 minus h. Now see, h lies between 0 and 1. So this difference 3 minus h must be greater than 0. So if we take p as minus h plus 3 or 3 minus h, then p is greater than 0. So now we have to take mod of p is equal to positive p when p is greater than 0. So now in this case, this mod of minus h plus 3 can be written as positive minus h plus 3. So which is simply a minus h plus 3. So now we can write the left hand limit as limit h tends to 0, and mod of minus h minus 3 is simply h plus 3, and here we have the negative sign. Then mod of minus h plus 3 is minus h plus 3, and in the denominator we have minus h. So let us simplify the numerator. So here we have h plus 3, minus and minus plus, and here we have minus 3. So in this case we have minus h in the denominator. So now again this 3 and this 3 get cancelled, right? And we are now left with limit h tends to 0. H plus h is 2h, and here we have minus h. So now this h and this h get cancelled, and we are left with limit h tends to 0, and here we have minus 2, right? And since this expression is independent of h, so we can leave this limit notation. So we have simply minus 2. So we can see that the left hand limit is equal to minus 2. So now we have calculated the right hand limit as minus 2 and the left hand limit as minus 2. So we can easily conclude that the right hand limit and the left hand limit both exist, and both are finite, right? So the right hand limit and the left hand limit both exist and finite, and they are equal to each other, right? So the limit of this function, it exists at when x tends to 0, because if we have a function, say y is equal to f of x, and if we are to find out, or we have to discuss the existence of the limit of this function y is equal to f of x when x approaches to a, then we find the right hand limit, which is given by limit x tends to a positive f of x, and then we find the left hand limit, limit x tends to a negative f of x. And if these two limits exist and they finite and they are equal to each other, then we can claim that the limit of this function when x approaches to a, this limit exists, right? And the value of the limit, this limit is equal to minus 2. So to summarize this discussion, we have seen that the right hand limit and the left hand limit both exist. They are finite and equal to each other, and the common value is minus 2. So we can now claim that the limit of this function is equal to -2, and the limit of this function, it exists.